between a and b, the interval a and b, is 1 over b minus a, the integral from a to b from f of x dx. I have to find this integral, and that would be the function average value on the given interval. So there is nothing else. We haven't looked at anything else in 4.4. Now going back to 4.3 is area. So in 4.3, let me go back, 4.15. So one option is find the total area. So we know how to determine this area, right? It's the integral between 0 and 2 from f of x dx. But if we have two functions, where are two functions here? We want an example with two functions. Where are my examples with two functions where we have to graph? I think they're in 4.2. Yeah, they're in 4.2. Sorry, not in 4.3. Okay, so for example here, if I'm asked to find the area, all I have to do is the integral from 0 to 2 from f of x dx, and I will find this area shaded in. What can a word problem, and we know how to find the integral, the definite integral. Please do not change the definite integral into an indefinite. Do not go back to the original variable. Please do not do that. Please. One more time. I saw it in some of the homeworks. Please, this is a definite integral. If you're using a substitution, all you have to do, if you're using a substitution, you don't go back. If you're not using a substitution, then you're fine.
I have a question.
Yes.
What do you mean by that? So there's like no issue in going back though, right? It's just like a longer process.
There is no issue of going back. However, there is no need to do that. And so that's a very good point. So for example, let's say I have the integral from 0 to 1 from f of x dx, and you write the integral from g of t dt, and you copy the limits of integration, then I can't give credit. Because when you go to a different function, to a different variable, you cannot copy the same limits of integration. I've seen in some of the homeworks, students just change this into an indefinite integral, found whatever plus c, and then went back and changed the integral again into a definite. So please do not do that. Whoever showed this doesn't know what's going on here. So
I have a quick question.
Yes.
So when we do change it into like u times du.
Right, so let's look at an example. Let's choose an example, but this is from the substitution rule. So this is from 4.5. Okay, so let's choose one and discuss it. 4.5, which page was that? I'm going back here, 434. So let's choose a definite integral so I can show this again. Any definite integral that you want to work on or with. Okay, what about 60? So everyone understands what I'm talking about. So the integral from 0 to 2 from 3x squared dx divided by 1 plus x cubed to the 5th power. So we have to treat this as a definite integral. We can't change it into an indefinite. Please do not change it to an indefinite. So as we know, I think we solved this problem together. So I'm going to let u be 1 plus x cubed. I have to determine du as 3x squared dx. And then I have to change the limits of integration. When x is 0, u is 1. When x is 2, u is 9. And then the numerator here is just du, and the denominator is u to the 5th power. Do not go back. Please make sure you're writing the correct limits of integration. So this is u to negative 5 plus 1 over negative 5 plus 1 from 1 to 9. If I see a constant here, which there is no need for a constant, then I know that you are not following the steps, the correct steps. So please do not change this into an indefinite integral. Please do not write a constant. Please write the correct limits of integration if you are using a substitution and move on. So this in front I have negative 1/4, and this is u to negative 4. So 9 to negative 4 minus 1 to negative 4. This is what I want to see. And then the arithmetic you don't have to perform. Okay? You can leave it alone if you don't want to calculate it. I don't need approximations. You don't need to punch it in the calculator. This is good enough for me. Does that clarify the question or the issue here? Is that better? Yes?
That means we cannot put the 1 plus x to the power of 3 instead of u.
That's what I did. So it's right here, u to the 5th power. That's u to the 5th power.
No, we don't substitute after we did that. That's what I'm questioning.
It's a number. We're not going back.
Okay.
The answer is a number. We're not going back to anything. We're not looking back for definite integrals. For indefinite integrals is a different story. So now let's choose an indefinite. So let's choose an indefinite, please, to clarify that too, one more time. For indefinite integrals, I have no choice.
28.
28. Good. Which page am I on? Is it 8? Yes. Good. So you said 28. Perfect. So we have the integral from x to the 3rd minus x squared minus x. And this is power 9. And then 3x squared minus 2x minus 1 dx. Perfect. So obviously this is the problem because it's power 9. So I'm going to say let u be x cubed minus x squared minus x as long as du. So please carefully identify the substitution, carefully present the differential. And I see I'm in business. Why am I in business? Because this is du. And this is u to the 9th power. So then I have u to the 10th over 10 plus a constant c. So maybe I should write this intermediate step, u to the 9 du. And now I have to go back. I have to replace u, which is x cubed minus x squared minus x to the 10th power divided by 10 plus a constant c. I have to go back to the original variable because this is an indefinite integral.
Thank you.
Very good. Does that clarify everything now?
Yeah.
Okay, so back to, we were discussing 4.2 again. 4.2. Yes, 402. We just talked about this today. We looked at another approximation. So basically, in this section, you can be asked to approximate the total area under the graph with the leftmost point or rightmost point. So now it says total profit. So a concert promoter sells X tickets and has a marginal profit. It tells me I'm giving you the derivative. Find the total. Find the total profit from the sale of 75th through the 300s. So it's very clear. I have to integrate this function from 75 to 300. And the last section 4.1 is basically pretty much the same idea, but here we're asked to find the function, basically. So that's page 393. So total cost from marginal cost, pretty much the same thing. Find the total cost function assuming that C of x is in dollars and that fixed costs are, in other words, when x is 0, C is 6,500. So they are giving us the point to find the antiderivative. So here we are finding just the general function, which is a general antiderivative, but we are given a condition to find the constant. Do you feel a little bit better? Is there a particular problem that you would like to go back to from what we discussed so far? And this is all for test 3.
I feel better.
Any particular one that you want? We have time. We have 20 minutes. Let's work on anything. What would you like to? Yes?
So on the last review, yeah, you went through and listed like the major concepts that
Yes.
were throughout this chapter. Could you
Yes.
do that right
Yes.
now?
Yes.
So that I could go back and
Yes.
do
Yes.
those myself.
Yes. Chapter 4, Chapter 5, Chapter 6. Here, evaluate. Like f of x, y, z. Number 2, linear regression. Number 3, the d-test. Finding max, relative max, min. And number 4, finding, which is basically in the d-test, finding fx, fxx, fyy, of course fy, fxy. So that's basically it. And domain. In chapter 5, we only have 2 topics: differential equations and a consumer surplus and producer surplus. Nothing else. And in chapter 4, we have definite plus indefinite integrals with a substitution when it's needed. Approximating areas. Finding, like we just had, if I'm given, let's say, r prime of x, find r of x, or find total profit. Oh, it's a revenue. If I'm asked to find the function, that's the most general antiderivative. If I'm asked to find the total, then the total revenue is the definite integral, r prime of x. And this one is just a function. I can't think of anything else. I'm just flipping pages. One thing that I want to add here for sure. Oh, yeah. The average value that we just discussed here, please. F average. Okay. So don't forget that. And areas between curves. The last one. Areas between curves. Functions. So when we look at the areas between curves, you must graph the functions. Don't just come up with something, an integral, please. Let's work on a problem right now of that. Because I saw in the homework question, you did not graph. Many of you did not graph. You must graph. No credit without graphing, please. So I'm looking at page 425. Let's say, I don't know, 17. So y equals x plus 2 and y equals x squared. So I have to graph. I have to show the area. I have to shade it in. Without that, I can't look at the integral. I don't know how you got the integral. So first I graph this, which is the easiest, right? So y equals x squared. And then when I graph y equals x plus 2, I need 2 points. When x is 0, y is 2. So 0, 2. When y is 0, x is negative 2. So negative 2, 0. So now I have the graph of the second function. Negative 2, 0, and 0, 2. And this is y equals x plus 2. I will extend this, of course. Now I see where the area is. I am going to shade it in. Now I need to find the points of intersection. Once I find the points of intersection, I know the area is the integral from this to this, from above minus below dx. Above is x plus 2, below is x squared. But now I have to determine these limits. So I have to set these two equal to each other because y and y are the same. So x squared equals x plus 2, or x squared minus x minus 2 equals 0 if you don't want to factor, although it's too easy. You can use that app. So I have x equals 2 and x equals negative 1. This is at negative 1 and this is at 2. Negative 1 to 2. So please understand, without graphing the functions and shading the area, this means nothing. Getting some integral by guessing, that's not what I'm interested in. So we have to graph both. I have to shade in the area. I have to find the limits of integration by solving the system. I use substitution because I have y and y, so I replaced this y by x plus 2. And then I find the integral.